So a function receive input, process, and then output. That's a theoretical way to say what a function does. So to define function in Python, you use def. The next thing is the name of the function, followed by the parameter. Remember I said that function receive input. So you can depend on what your function is supposed to do. That will determine how many inputs that you might need to have. If you need to find an area of a circle, what do you need to find area of a circle? That's pi r squared. So your pi is a constant, square is a constant, and then the only thing you need is the radius. Radius becomes the only input that you need to have in that function. In this case, because we're just creating an example, we can have as many parameters as we want. So for the purpose of this explanation, we'll just say 2 parameters. So we have parameter 1 and parameter 2. This parameter can also have a type, because remember the example that I mentioned that you have finding the area of a circle, that the only input for finding the area of a circle is radius. And radius obviously should be a float or an integer. So float is better. So if you create a function and you pass a string to such kind of solution, it should give you an error. So you should be strict in creating your function to say, oh, this is what I accept. So for area of a circle, you will be accepting float. So how do you determine the type that you accept? Is by saying column in front of your declaration of your parameter. So here I can say, oh, I want to accept an int. And the second parameter I can say, okay, I want to accept a list. So these are data types that we've talked about. Now that we've been able to declare a function, we've declared or decided to accept int as the first parameter, to accept list as the second parameter. What do you think is next? What will be the output of our result? Using the same example, area of a circle, the output is still going to be a float, because if you do 22/7 times your radius, square it, you're still going to get a float. So you then need to define that your output should be float for that example. In this case, we can decide whatever it is. We don't have a problem we're solving now. So we're just, putting different examples together in terms of different data types together, just to show you that it's possible. Okay, how do you now specify what your output should be? Is by specify dash, then arrow. This arrow kind of a sign. This is right greater than sign. So you have a dash, then greater than. And what follows next is your data type that you want to export, that your function should export out to whosoever is calling it. And I can say set. So of course, you guys know set data type. And once I'm done, I terminate with my column. And once I terminate, I can go ahead and then put the body of the function inside here. I can write my code and then, do the needful. So one of the things about function is that it has an input, it has a body, and it has what? An output. Okay, so create a Python function to find the area of a circle. Cool. So let's create the function. How do we start creating a function? Def, right? And what do we call the area of a circle? What's the name that we want to call it? Area of circle. And what are the parameters that we need in finding area of a circle? 22, that's pi r squared. Pi is a constant, so we don't need it. It's a constant anyway. We don't need to pass it as a parameter. R is a radius, which is what we need from the user. So I will say R, which is the radius, is a parameter. So what is the data type of R? Of course, float, because it's numbers. So we will use what? Float here. Obviously, our output will also be what? Float. So you use your arrow, dash arrow, and you say float. And you terminate with column. So you are done with the definition of the function. The next thing is to start coding the program to do the maths for you. So I will say pi is equal to 22/7. That's our constant. So we'll use it in our calculation. Then the next thing I want to do is to say my area is equal to pi multiply by radius, which will be provided by the user. Then how do we do raised to the power of 2? We did this in operator, guys. So we do exponential is denoted by double asterisk. So this will give you exponential. So you want to do something like this because you want this one to be calculated separately before you do the multiplication. So you don't want to multiply this first before you now raise the value to the power of 2. So you want this to happen first before this one, then multiply by this. So now that you've done the calculation, how do you return your information back to the person that called it? You use the word return keyword. What are you returning? You are returning area. So let's go ahead and see how to implement it. What we've done here is just, what's it called now? Is a function. If you run it, it doesn't do anything, guys. This is a function. It's just sitting pretty. You need to make use of it. So how do you make use of it? You need to say, let's go ahead and print something and say, your area of a circle, you now put in bracket. Do you see the requirement is saying float or all these things there? So you can then put your 6.4. And of course, you can make your 6.4 a variable so that you can change it at will and do your testing anytime. So you can make this one n, and you can make this happen like this. Okay, so yeah, fingers crossed. Let's see if it will work. So when we run it, it says area of a circle with radius 6.4 is equal to all these guys here. So you can, run so many things and try it out. So you can press your calculator and check the formula. So this is how to get that function working. Another way to format this output. So I'm going to write another one on the bottom. This is a way to format this output. There's another way to write this output. And that output, that way is to format, to use a F, word. So this F is used to format whatever is here to make it look differently. Meaning when you use F, you can actually put your code, or rather your variable inside this string. So instead of having comma, 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 comma like this, you can have everything. I'll show you the difference. So instead of having comma like this, I believe this comma was easy to explain when I explained it. I wanted us to go deeper in the course of the material before I started showing this one. Now that we've done something like this, we've added the F to it. There are variables inside this string, guys. So those variables need to be extracted in such a way that it will show. Let me run it without doing anything. So if I run it without doing anything, it just prints the variable. But you yourself, you know that n is a variable. This guy is a whole function on its own. How do you output it? So you use curly bracket. So immediately you specify curly bracket, it makes sure that this n is processed like a variable and not like a string. So running this alone will give you this part. Then you use the same thing to do this part. So it evaluates this one on its own and not treat it like a string. Okay, generate odd and even numbers. So clue to this one is that your stepper is very important, and where you start with is also important. So if you start with 0, you get even numbers. How do you do odd numbers? You put 1 here, so your starting point will then now be 1, 3, 5, 7, 9. It will still skip 2, 2, 2, 2, 2 like that. Okay, the prime. Start with natural numbers that you know. Let's check from 3. So I'm in 3 now. I want to run myself down, as in I want to look down at these numbers. So I'm on 3. I'm saying now, can 2 go in 3? The answer is no. Can 1 go in? Well, apart from 1. So 3, because nothing can go in 3 from 3 downwards. No, all these guys cannot divide me. So I'm a prime. 4, I can divide myself. Okay, I'm still like a prime. 3 cannot divide me, right? I'm a prime. 2 can divide me. It disqualified me from being a prime. I did not add it to the list. So 4 is not in the list. 5. I can divide myself. Yeah, I'm a prime. 4 cannot divide me. 3 cannot divide me. 2 cannot divide me. 1, like that. That's how you solve for primal. This thing I'm explaining that is looking like, it's just English. That's how it is. The way I'm doing it. So that way that you identify that number, and you know that you need to use the lower number to check. You see the way you are checking the lower number, you need to program it that way. That's how you need to program the code to work. So let's do n. N is equal to 10. And we do in range. So you can start from 2 to n. Then print I. So you can see your numbers here. Remember the formula that we cooked up. So let's start from 3 set. Remember what we cooked up, that from the first thing we work our way down. Remember? So how can you work your way down? What's that code that you can use to work your way down? How can you check 3 against 2 and 1? How can you check 4 against 3, 2 and 1? How can you check 5 against 4, 3, 2 and 1? How can you check 6 against 5, 4, 3, 2 and 1? That's where you need another loop. So because inside, when you are in 3 now, you need to loop through 2 and 1. So you need to go another loop. So how do we create another? Because this is a loop. This loop just prints this result for us. So let's go another step deeper. So that loop will now be from where to where. So I will do for J, that's the next illustration. So I'm ranging into start from beginning and stop. You can also start from 3, since 3 is the beginning of what we're checking. It will stop at the current value, which is I. So we are gonna do a test to see if it's bringing what we want to bring. And again, always print out your result to see where you are in what it is you are doing. So the first value, I will say this is the main number, right? This is the main number, which is I. The second number is going to be the divisor. Like this one is what God wants to use to divide this one. So let's go ahead, guys. So I've already done this first one. This first result, look at what it does. This one just gives us main number is 3, main number is 4, main number is 5, main number is 6, like that. Then I want to now say inside the main number is 1. I want it to be able to say main number, check it with 3. Check it, as I said, I will check 3, 2, 1. 4, I will check 3, 2, 1. 5, I will check 4, 3, 2, 1, like that. I will check 3 against 2. I will check 3 against 1. But we know 3, so we're not checking 3. So let's say 7, for example. I will check 7 against 6, 7 against 5, this same 7 against 4, this same 7 against 3, like that. So 8, I will check 8 against 7, 8 against. By the time you get to 4, you will see that 4 can go into 8. So enter the list. So that's what I'm doing, guys. So these 3 lines, I'm sure you understand these 3 lines. N is 10. For I into range 3 to n, print main number is I. That one is solved. The next one is I'm now going inside. So this is the part that might look confusing, but like I said, it's just a simple stuff that's going on here. So I'm creating another loop. And what this loop is doing is that, of course, I have to use another variable name, which is J. Range of when, I'm also starting from 3 because that's our starting point. And I'm stopping where? I'm stopping at the current point that I is. In this case, I is 3. So if, let's say I is 7, so I'm going to be counting from 3 to 7. So I'm going to be saying divisor is this. So let's try it. Let's try and run it and see our results. So if I run it, of course, it's going to give us a weird stuff, but you have to have that mental capability to straighten things out. So 3 and 3 will not really, say too much. So it's more of like from 4 that the main thing is going to start coming out. So look at these two things. Do you see what's happening here? Main number is 4. divide by 3. You see what's going to happen? It's going to check 3 and 4. If I can find the stuff, I will do the math later. So look at the next one. Main number is 5. Do you see what happened? It's checking 3 with 5 and it's checking 4 with 5. Let's go to the another number, 6. Do you see what happened? 6 is checking 3, is checking 4, is checking 5. Cool. What happened to number 7? It's checking 3, it's checking 4, it's checking 5, it's checking 6. Do you see what's going on, guys? So it means I can use this method to say, oh, can 3 go in 8? Can 4 go in 8? Ah, yes, 4 can go in 8. So therefore, 8 is not a prime. This is the method I'm going to use, guys. I've not done anything special. You can see that there's no any special. And this is because I could reason the code. I could solve it just by looking at the number without coding. Let me introduce it back again, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. No coding. This is just normal common sense, guys. No coding. I just say, okay, this number, how can I figure out if it's prime or not? How did they figure it out? And this is the key to programming, guys. If you get this, you don't have any problem programming again. Don't rush to coding. First, figure out what they are trying to say. And from the numbers, you can figure. So once you know what it is they are trying to do, then you now have an algorithm. You now have a step to work with. You have a step to work with. So let's go ahead and solve this. The main, which is I, remember that your main is I, guys. Your I. So your I mode, your J will give you a value. So let's check what I mode, that guy is. So if you print, when you are doing your division, our check is in the front. So I'm checking for, let's start for the one that we know that is not, like 8, for example. So anywhere you have 0, it means 8 is not a prime. Because when you do 8 divided by 4, you have 0. It's not a prime. Wait, let me make sure that my, yes, that's true. You also have 9 and this. So let's start from beginning. So we are doing division check. We have 1. We checked another one as well. 5, we have this. 6 is not because we got 0. 7 is we have a value. 8 is not because we had a 0 at some point. At some point when 8 was checking all the numbers, remember this, so I will still bring this out. Remember this. At all points, if 8 is checking 7 out, it will get a remainder. 8 is checking 6 out, it will get a remainder. 8 is checking 5 out, it will get a remainder. 8 is checking 4 out, it will get 0. Do you see, guys? So anytime that you get a 0, it means that number is not a prime. So the next thing you want to do is to do a check, because what I did here is just to print the mode. So we know what we want to do now. We are targeting 0 when it's equal to 0. So I can then do an if condition here. If now, while we are inside here, because this is where the main thing is, we need to set a flag. So what is a flag? A flag is like something to make sure that we blacklist something. Like, this guy, you are not, so just stay one side. So how can we set that flag? And once we set that flag, we should just keep off that guy. So that flag is set whenever we have this one is equal to 0. And that's what we are going to set here. So I can call that flag is prime. Okay, so let's say it's true by default, because whenever we now encounter 0, that's when we now say it's not a prime. So whenever we start the loop, make the first item, any item you see, say that is a prime. Any item, just like we're starting from 3 now, we just say 3, you are a prime directly. So that's what this one is saying. Then when we now start looping and we are doing our checking, anytime we now see that the value is 0, definitely our prime should be false. Our prime should be false. So we're now setting that flag that anytime you see that this is 0, set the prime to be false. Because our loop will go back to the beginning to 6, what do you think will happen? It will start this whole journey all over again. Now that we set our prime to be true, we now come down. Look at the line that I'm following. We now come down, and once we are done, we can now append to our prime list. So let me call it list, that list 1. Let's still use our list 1. So what am I appending now? I'm appending my I. But before I append my I have to make sure that prime is actually true first before I append my I. So I will check if prime is true, then append my I. So let me explain the code again, guys. So in the beginning of the code, I said that prime should be true by default. And this decision was based on the fact that I was looking at this, stuffs here. So now that I'm inside the loop to check, you guys understand all this one. So whenever it is equal to 0, whenever you see this modulus and is equal to 0, it means it is not a prime. And we can check that with all this checking we've done. Whenever it's 0, it is not a prime. So therefore, set that it is not a prime and break. But coming outside, look at where I break, guys. Coming outside, still check. So that if it's still a prime, then that's when you can do your append. Like I said, we needed a flag, so that by the time we exit the loop, we will still check if that value is a prime or not. So let's go ahead and give it a test. So I should have 3, 5, 7, 11, 13. I think this is correct now. This is the list of our all prime 1 to 15. So I'm going to put it to 100 and run it and see if we have something that makes sense. Let's go and see if we have numbers that make sense. So we have 19, 23, 29, 31, 37, 41. So I think all these numbers are all prime, guys. And you can see the code is checking everything. You can see if you go through the checking. So if you look at 97 now. So 97 is going through 2, check 3, check 4, check 5. Making sure that none of these guys can actually divide it. Do you see? It's checking every one of them. It's checking every one of them. And he has to check it till it gets to 90 something. And once it's done, he didn't find anything. It goes. Look at 98, guys. 98 was divisible by 2. It just stopped. It gave up. 99 is divisible by 3. Do you see, guys? So turning this to a function, pretty easy. Let's turn this to a function, guys. So how do we turn it to a function? So let's write a function. I'm just gonna put everything inside a function scope, and I'm gonna say def. I'm gonna say list prime. I'm just gonna call it list prime. Then what are the parameters that I want to accept? Just one parameter, and I'm calling it number. Then is an int. Then what am I returning? In fact, I can return a set. Very interesting, because set is supposed to be unique. You're not supposed to have duplicates, so it's unique. So everything here, I'm just gonna tab it a little front. I'm gonna use tab to put it to the front. Since I have n here, let me just call this n, so that to just make use of the n here. Then I'm gonna delete this n. Again, remember indentation. I'm going to indent all this one to front by 1. I'm gonna copy all this in here, and I'm gonna do tab. So everything here now is now a function called list prime, so that in my code I can just say print list prime of what. I can say of 100. Then let me remove all this one here, and let me run this now and see what it says. Okay, we didn't return anything. That's what happened. So because you wrote your function, you didn't return anything. Let's return something, guys. And our return is going to be our list of the prepared stuff, what we have here in the list. So it's going to be in this level, guys. In this level, that's where your return is going to be. So you have return. I'm returning a set. So how do I cast this to set? I just do set, and I put everything in brackets, and that becomes my set. So I can run this again and I have this. Let me give you guys assignment. Write a Python code to find the factorial of any number. Remember what I told you guys. The first thing is you understanding what factorial is and breaking it down gradually. In fact, open paper, solve it with your hand. Solve it. Once you solve it with your hand and you see the repetitive pattern, that repetitive pattern is what you program and then you execute. Without you solving it, without you knowing what factorial is, there's no magic on it. You cannot write a code for it.